This session we'll see one of the first solution that is called lock variables. So here lock is a global variable shared by both the processes. So assume there are two processes, process naught and process 1, and they are accessing global shared variable that is lock. And a lock is a Boolean variable which can take 0 or 1. 1 indicates it is locked, 0 indicates it is unlocked. So initial value of lock is equal to 0. This is the first assumption. So lock is a Boolean variable. 0 means unlocked, 1 means locked. And initial value of lock is equal to 0. It is in unlocked mode because first process at least could enter into the critical section. So when let us say I'm talking in the favor of process P0. When P0 is entered, it is setting a lock is equal to 0. And it is cross verifying that while lock is equal to 1. Right now, lock is not is equal to 1 because lock value is initially how much? 0. Then in this case, this condition becomes false. When this condition becomes false, you are entering into critical section by making lock is equal to 1. So when you are making lock is equal to 1, it indicates that it is locked. So I can access critical section happily. After completion of that, release the critical section by unlocking the critical section, which is nothing but set the lock is equal to 0. Here, there is a one important concept is while lock is equal to 1 and the terminator. So if this condition becomes false, you will be under. If this condition becomes true, you will be under waiting. If this condition becomes false, you are breaking the while and entering into the critical section by setting lock is equal to 1, access the critical section, and while leaving, set the lock is equal to 0. So other process could get the chance to enter into critical section. Now, we will talk in the favor of this time process P1. It knows that lock is equal to 0 initially. Again, same story. While lock is equal to 1, and it sets the lock is equal to 1 and enter into the critical section. While leaving, make the lock is equal to false. So what is an idea? I will show you. Is it satisfying the three properties like mutual exclusion, progress, and bounded waiting? What is a mutual exclusion? Only one process could enter into the critical section. Let us check. There is a pre-node, there is a P1, and initial lock is equal to 0. So I am entering by checking the entry section. This is only your entry section. Entry section is nothing but checking the validation. Here also the process 1 supposed to perform entry section. What is a while condition? While lock is equal to 1, then you will be in infinite loop. This side also P1 is supposed to take care of that. While lock is equal to 1, then you have to wait. If this condition falls, it breaks the while loop, you can enter. For example, assumption lock is equal to 0, process 1 initially initiated to access the critical section. While lock is equal to 1, we will say that the condition becomes what? False, because lock value is initially 0, no other process is there right now. When this condition becomes false, you are using lock is equal to 1 and saying that you are in critical section. While leaving, then you set the lock is equal to 0 so that this will be a reminder to other process to enter into critical section. Same way, once the P1 task is completed, then P2 enters. Lock becomes right now 0 because already P1 made it as a 0. Entry section we are checking using while lock is equal to 1. This condition becomes false. Then you say that lock is equal to 1. And once it is true, you are entering into critical section. While leaving lock is equal to 0, then executed successfully. Positive way. The algorithm approach I have discussed so far in positive way, it looks that it is a perfectly implementing critical section. What is the flaw? Let us see the flaw now. There is a mutual exclusion I would like to satisfy with the algorithm, but I will say a flaw now. Observe carefully. Lock is equal to 0, P0 and P12 processes. First P0 initiates that I like to access critical section here only, which is under protected mode, which consists of shared resources. P0 is cross-verifying while lock is equal to 1. It is false. It is a false. Then immediately you notice it that it is a false. Then what happened? P1 preempts here. P1 preempts P0 exactly here only. Before you set the lock is equal to 1, you got the preemption here. That's it. P0 suspended, P1 got the chance. So let me write step by step. First P0 initiated. Then second step, P1 preempted P0. Then what is the issue? Still lock is available with 0 only because P0 has not got the next line to enter because I got suspended by P1. Then P1 took the control. It is now checking itself that my side. What is my side? Same story. While lock is equal to 1, is it true or false? Again, he noticed that it is a false. If it is true, then you will be underweighting. It is also false because lock is equal to 0. Then you are entering now lock is equal to 1. Imagine this time P0 preempt P1. P0 preempt P1. That's it. Now, right now, P1 got the control on the first line, and now this guy got control. P0 got control, and he also set lock is equal to 1. He also set lock is equal to 1. That's it. Both processes condition becomes false, and both are set lock is equal to 1, which indicates that after some time, your critical section consists two process. One process P0 is inside and other process P1 is also inside. This ensures that mutual exclusion is dissatisfied. Mutual exclusion is dissatisfied. That's it. If you lost the mutual exclusion property, and you can't say that this is one of the best algorithm because algorithm supposed to satisfy at least mutual exclusion. If your algorithm provides all three, we never mind. But if algorithm satisfies ME, then we will go ahead. Otherwise, we will say that this is a failure algorithm. Again, I am repeating, this is a failure algorithm. So what is the remedy? The remedy is just a small enhancement is applied to the lock. The lock algorithm has given some enhancement such that, what is that enhancement? I will show now. The enhancement is there is a P0 and there is a P1. This is a enhanced version or second version of lock because first version is dissatisfying mutual exclusion. So both are accessing lock is a global variable which is under shared and both would like to access critical section. What is the enhancement is given is while lock is equal to 1 and lock is equal to 1 are combined together. Now they become what? Atomic. What is the meaning of atomic? They cannot have preemptions between while and lock 1. Earlier, I have given this. The preemption came between lock and while statement. So here we are saying that the lock and while are completely attached, they are not detached. And here also, as this algorithm is improved version, P1 also has the same piece of code. While lock is equal to 1, then lock is equal to 1 is not a separate statement, it is a combined statement. When I say it is a combined statement, then it is nothing but a what? Atomic execution. The meaning of atomic execution is you can't detach them. You can't give preemptions in between while and lock. That's it. You are entering the critical section. There is no modification in the next two other statements. Now, with this improvised version, am I able to go into the critical section two processes? Let us cross check. First, P naught initiated. Observe. First, P naught initiated. He checked lock is equal to 0. So while lock is equal to 1, condition becomes false. Then I want to give a preemption now. P1 would like to give a preemption exactly like the previous case which I quoted. So P1 try to preempt P0, but this is not possible. Why this is not possible? Because while and lock statements are not separated. They are in a combined unit, so you can't give the preemptions. Once you are failed to give the preemption, then P0 continue execution. P0 goes, lock is equal to 1, it enters into critical section, lock is equal to 0. You may get a doubt here that can P1 give the preemption here? Can give the preemption here? Where? After your lock statement. After your lock statement. Can P1 give a preemption here? Already statement 1 is completed. Statement 2 also completed. Once statement 2 completed, as you are unable to give the preemption between while and lock, so it is not possible. Then P0 is inside the critical section. Then P1 is trying to preempt here. What is the use? Yes, I can give preempt here because atomic completed. Now it is a free line, individual line. P1 preempt P0. This is true. Then I'm checking P1. P1 side I'm checking because I got the preemption. How you are checking? P1 side I'm talking. Your preemption got successful. You are suspended P0. But imagine P0 is already inside critical section because of my first two lines are satisfied. P1 preempt P0. Now look at the P0, P1 case. What is the P1 case? P1 is checking its own piece of code, line number 1. What is the line number 1? While a lock is equal to 1. I am checking P1 this time because P not suspended. And you observe that lock is equal to already 1 because P not made it 1. Then your condition becomes true. Then you are under waiting. This is how it is a proving what? 100% mutual exclusion because only one process is allowed to access what? Critical section. So just a small adjustment is done to this solution. What is a small adjustment? Combined while and lock statements together. That's it. So that is a solution. If you observe the solution carefully, you will understand. So while lock not equal to 0, which is nothing but is equal to 1, lock is equal to 1, critical section, lock not equal to 0, lock is equal to 1. This is a version 1, my dear friends, observe carefully. This is not a version 2. In version 2, yeah, this is version 2. In version 2, your lock 1 and while statement will be in bounded. They will be not separated. You can't give the preemptions. That's kind of concept called atomic execution. In version 1, the sequence of lines I have mentioned, which I explained, you also can go through. First P1 while statement, this becomes false. Then P2 while statement, this also becomes false. P1 is equal to lock 1. Yes, both can go inside the critical section. This is failing the properties of what? Mutual exclusion. So this is updated with the version 2 by making some change that while statement and lock statement together in a single block. Therefore, I can't give any kind of preemption. I in the sense other process can't give any preemptions when a one process is inside the critical section. And you can't give preemption between this line and this line because they are what? Indivisible. Indivisible instructions are called what? Atomic execution. This is a perfect algorithm. And is it satisfying progress? Is it satisfying progress? Yes, of course not. Yes, of course, it is satisfying progress also because one by one process is going. If at all the critical section is freely available and only one process is trying to access every time lock is equal to 0 and I am checking while lock is equal to 1 or lock not equal to 0, whatever it may be. If this is true or not, this is true, then I can set lock is equal to 1 and I can access critical section. Once my task is completed, lock becomes 0. Then again P naught can go inside. Again, second time, first time completed, lock is equal to 0. Again, while lock not equal to 1 and lock is equal to 1, critical section. Likewise, how many times you would like to access critical section, you can go it. Therefore, it is satisfying progress also. And third one is a bounded waiting. It is satisfying because this is only for what? Two process solution. This is the beauty. It is a two process solution. The second variety is a strict alteration. Strict alteration, also known as Dekker's algorithm. It is also two process solution. So there is a shared variable called turn, also known as wanted. It is shared Boolean variable. The variable is shared only by two process because the solution is not for a multiple number of process. The solution is available only for two process solution only. Initial value of turn is equal to 0 or maybe a 1. It can be 0 or 1. A process must acquire lock before entering into critical section. Every process must release lock after completion of execution. Advantage is ME, bounded waiting, satisfied, but drawback is what? Progress dissatisfied. How this solution is achieving mutual exclusion and bounded waiting, and it is dissatisfying no progress. No progress means if a process already accessed the critical section one time, immediately you can't access the critical section. Some other process has to go inside by force and he has to wake up you. So once your turn is completed, you will be entering into sleeping mode. So you need to be wake up by somebody else. That is a strict alteration. Strict alteration means one time process access critical section, then other time P1 access critical section, and the next time P1 got P0 got critical section, and next time P1 got critical section. So P0 wake up P1, P1 wake up P0. That's why P0 cannot continuously get the critical section concept. Let us see the algorithm. This is the algorithm. There is a shared variable. There is a shared variable turn is equal to turn is a shared variable. The initial value may be 0 or 1. But earlier lock algorithm, the initial value of lock is equal to 0. But it is given a free hand. The turn can be 0 or 1. Every process has a piece of code. Same piece of code will be having by each other process. While true, process initially consists non-critical. It's a regular. because every process has non-critical section where it consists of non-shared resources. And you're supposed to go for validation using entry section here also. What is the validation? While turn not equal to 0, while turn not equal to 0, then you have to wait. If this condition falls, you're entering into critical section. While leaving, you need to keep the turn is equal to 1 and exit section, reminder section. This side, non-critical section, entry section, but this time condition is different. While turn not equal to 1, it is not belongs to me. Earlier, while turn not equal to 0, it is not belongs to P naught. Here, turn not equals to 1, that means not belongs to P1. If this is true, then you will be under waiting. If this is false, you enter into critical section. While leaving, go to turn is equal to 0. That means you are waking up process P naught and this guy is waking process P1 by making turn is equal to 1 or turn is equal to 0. Let us see how it is satisfying mutual exclusion and bounded waiting, and it is dissatisfying progress. Let us say process P0 and process P1. Both are using this time Dekker's algorithm. Both are using this time Dekker's algorithm. Dekker's algorithm only for two processes only. What the Dekker algorithm is saying, initially turn value may be 0 or 1 and turn is a shared variable. And what is the condition? While turn not equal to 0, waiting. Otherwise, you can access critical section while going turn is equal to 1. And here, while turn not is equal to 1, critical section, while going, you make turn is equal to 0. So now we will cross check ME satisfied or not. Let us see. Preemptions all are there. Everything is there. Preemptions also you can apply. So line number 1, this guy is executed. That means P naught initiated. So when P naught is initiated, while turn not equal to 0, you need to say that what is the turn value. This is very important. What is the turn value you are coming? Is it a 0 or 1? Imagine first step is turn is equal to 0 only. Let turn is equal to 0. This is the piece of code for P naught. This is the piece of code for P1. While is supposed to be with the semicolon. Semicolon indicates do skip. Let turn is equal to 0 and P naught initiated, P naught started. Let us see what will happen. P naught, while turn not is equal to 0, because your turn value is equal to what? 0 only. Turn not is equal to 0. It is 0, right? It is not equal to 0. Then when this condition becomes false, when this condition becomes false, then you can enter into critical section. So if at all turn is equal to 1, what will happen? If turn is equal to 1 and P naught started, 1 not equal to 0, yes, then you will be under where? Waiting. Please listen carefully. Observe carefully the piece of code. So I'm going line by line. Let turn is equal to 0, P naught started, and P naught checking the while condition while turn value is not is equal to 0, but it is 0. Turn value is 0. Therefore, you have break and while condition. While becomes false, then you are entering into a critical section. Then while going, you are making turn is equal to what? 1. And next, line number 3, P1 initiated. P1 initiated is checking while turn not equal to 1, turn value it is 1 only, it is false. Then P1 also can enter into critical section while going turn is equal to 0. It's a beautiful algorithm, excellent approach. But what are the problems? Now we are checking for mutual exclusion. Preemptions now I will apply. So far I have shown you without preemptions. Now I will apply preemption. Line number 1, let turn is equal to 0. Line number 2, P naught started. P naught started. So P naught is checking the condition while turn not is equal to 0. Yes, it is a false. Now exactly this point, P1 preempt P naught. P1 preempt P naught. Now P1 got a chance. P1 got a chance. So P1 started and it is checking this condition this time while turn not equal to 1. This condition is a what? What is a turn value right now? Turn value is a what? 0. So 0 not equal to 1. Yes, it is true. 0 not equal to 1. Yes, it is true. When this condition is true, then P1 is under waiting, indefinite waiting. It's not a normal while. Observe, it is quoted with the semicolon, which indicates that do skip this statement. Do skip this statement. So P1 waiting. Who will get the chance? P naught got the chance. Then P naught can enter into critical section. While leaving, he say that turn is equal to 1. As soon as the turn is equal to 1, line number 5, as soon as turn is equal to 1, now he is under waiting, right? What is the turn value? Turn is equal to 1. Then this condition, 1 not equal to 1, 1 not equal to 1, it is a what? False. When this is a false, then what happened? While becomes a false, then P1 can enter into critical section. This is how you are satisfying a what? Mutual exclusion. Either turn may be a 0 or turn may be a 1. Either process will go into critical section, not the two process. You can give preempt anywhere, I don't mind. You can give preemption anywhere. So let us see one more example. There is a process P0, there is a process P1. Let turn is equal to 1. Now P0 initiated. P0 initiated. What is a P0 piece of code? P0 piece of code is while turn not is equal to 0. So 1 not is equal to 0. Yes, it is true. When it is a true, you will be under waiting. When it is a false, then you can break it. So you will be under waiting. Line number 3, who has to wake up him? P1 only. Otherwise, he will be under sleepy mode. P1 started and executing while statement at its side. Turn is not equal to 1. Turn value is equal to 1. It is started. 1 not equal to 1. It is a false. Therefore, you are entering into critical section. While going, you are making turn is equal to how much? 0. When you make turn is equal to 0, this condition becomes false. Then P0 can enter into critical section. When he entered into critical section, soon after released by the P1. Therefore, it's a paka mutual exclusion is satisfied. What about progress? What about progress? Progress is not satisfied because turn is equal to 0, line number 1, line number 2, P0 started. And P0 is checking while condition while turn not is equal to 0. This condition is false because it's 0. then you are entering into critical section. Then after that, you are making turn is equal to 1. That's it. This is the first iteration. This is the first iteration. Again, second iteration, same. P naught would like to go once again. P naught star line number 1. What is the turn value right now? Turn value right now you are updated as 1. Line number 2. Again P naught is like to go. P naught started. It is checking while condition that turn not is equal to 0. Yes, it is not is equal to 0 because you made earlier iteration turn is equal to 1. Now this condition becomes true. When this become condition true, then you will be, because of that line, you are under what? Waiting. So you can't go next time into progress. Next time into critical section. That means you are failing the condition of what? Progress. But dissatisfy bounded waiting. What is a bounded waiting? Once P naught come out from the critical section, P1 can go. If P1 come out from critical section, P naught can go. That's why this algorithm is satisfying mutual exclusion and bounded waiting, but it is dissatisfying about progress. Now we will see about another two-process solution that is based on flags. So it is a two-process solution. Flag is an array variable which is of Boolean type. Initial value of array, that is a flag of 0, flag of 1 can be true or false. A process must acquire lock before it enters into critical section. Every process must release locks after accessing critical section. Advantages: mutual exclusion, progress, bounded waiting is satisfied when no preemptions are there. But there may be a chance of deadlock. So this is the algorithm which is based on enable and disable flags. So last session we have seen about lock variable and turn variable. Initial lock variable is equal to 0 and turn variable is equal to either 0 or 1. So what this algorithm is, there is a flag variable, and as there are two processes, so flag is considered as an array with the two indices. One is a 0 and one is a 1, and both the flag variables may be true or false. So examiner will clearly specify initially flag of 0 is equal to true or false, or flag of 1 is equal to true or false. As it is a two-process solution, two processes are fighting for each other to enter into critical section. If we use the concept of enable and disabling flags, then it is obviously perfectly implemented algorithm, provided that deadlocks may be occurred due to preemptions. Let us see how this algorithm is achieving mutual exclusion and progress and bounded waiting. So this is as usually, while true, we don't mind. Our algorithm is this only: entry section, critical section, exit section, and remainder section. Here also same: entry section, critical section, exit section, and remainder section for process naught and process 1. So every process has to set their own flags. That's why flag variable may be a true or false, we don't mind, because every process is going to set on their own. According to this, initially flag of 0 is equal to true, and we will cross check while flag of 1 is equal to true or not. If flag of 1 is equal to true, then immediately this condition is going to be kept process not into waiting. If flag of 1 is not equal to true, which indicates that it is a turn to process not turn to process 1. Therefore, the while is a false. That means what is needed to enter the process not into critical section, flag of 1 is supposed to be what? False. That means flag of one value is supposed to be false. If flag of one value is equal to true, you will be under waiting. You can't enter into critical section. Then the turn goes to automatically process P1. Imagine what we are doing is assumption that flag of 1 is equal to false. And this side, flag of 0 may be true or false. We don't mind. So what happened? So when I say flag of 1 is equal to false, this condition becomes what? Flag of 1 is equal to true. It is a false. Then process not got a chance to enter into critical section. While leaving, we will say that flag of mine is equal to false. Here flag of 0 belongs to P0, flag of 1 belongs to P1. In the same way, the other side also, we need to have some kind of assumption. What other assumption is? P1, I am talking initially flag of not is equal to false. Now P1 is entered and intersection is going to check whether the particular flag value. So I'm setting myself flag of 1 is equal to true. I'm cross checking is there any other process in the critical section or not by taking a while. While flag of 0 is equal to true. If this condition becomes false, then you will enter into critical section. Otherwise, you will be in waiting. But according to this, flag of 0 is equal to false, which indicates that P0 is not in critical section. Therefore, P1 got a chance to enter into critical section. While leaving, you set yourself flag is equal to false because your task is completed. Let us see how this is satisfying mutual exclusion, progress, and bounded waiting. So mutual exclusion, I am checking between process not and process 1. What is the condition? Flag value, however you think, I don't mind. Maybe true or false. Let us say flag of 0 is equal to false. These are all let only assumption. And flag of 1 is equal to true. Flag of 1 is equal to true. Then what happened? P0 begins. P0 initiated. P0 begins. He is trying to enter into critical section. Whether he will success to enter into critical section or not. P0 is checking what is the algorithm P0 side. You need to set flag is equal to 0 and check other flag. I am saying my side flag of mine that is 0 is equal to true. Okay. Then initially it is a false. Then I am making it as a true. Then I am checking other process flag while flag of process 1 is equal to true or false. According to this scenario, I set flag of 1 is equal to true. Therefore, this will take you to waiting. So you can enter into critical section. Then who will get the chance? P1. Now let us say P1 side. What is the P1 algorithm? So flag of 1 is equal to true. So we are doing flag of 1 is equal to true. And I am checking while other process flag. While flag of 0 is equal to false. While flag of 0 is equal to false. Then the flag of 0 is equal to true or false. You made it as a true. Right. Though in this case, what happened? Flag of 0 is not is equal to false. So you also will be in where? Waiting. This leads to a situation called deadlock. This is only one of the exceptions there in this algorithm. And the rest of the case, this is what? Perfectly all right. Now, let us see its advantages like mutual exclusion, progress, and bounded waiting. So P0 side is setting flag of 0 is equal to true. And you say that while flag of other process 1 is equal to true. I'm begin with let flag of 1 is equal to false. Therefore, this condition becomes false. When this condition becomes false, you can enter into critical section, and while leaving, you're supposed to set a what? Flag of yours. Flag of 0 is equal to false. That's it. And in this case, P1 will start. Okay, first P0 got completed, and P1 is checking now. He is saying flag of 1 is equal to true according to my algorithm, while I am checking flag of 0 is equal to false. Flag of 0 is equal to true. Flag of 0 is equal to true. According to this, flag of 0, according to this, flag of 0 becomes what? False. Now, when the flag of, because they are global variables, right? Each can able to share them. After completion of P0, after completion of P0, after completion of a P0, then he himself said flag of 0 is equal to false according to our algorithm. Then he understand flag of 0 is not a true. Then this condition becomes false. Then he can enter into critical section. While leaving, he is supposed to set flag of 1 is equal to false. What do we understand here? When P0 after P1 uses, it is perfectly alright. Mutual exclusion is satisfied. Reverse also. If P1 started initially, after that P0 followed, in this case also, mutual exclusion satisfied. Okay, let us see the next one. Progress. How progress is satisfied? Progress indicates that the same process can enter into critical section n number of times. Let us say that flag of 1 is equal to false initially, and I am checking myself, P0 self. I am setting a my flag of 0 is equal to true, and I am checking a while condition, while flag of 1 is equal to true or not. If this is true, we will be under waiting, but according to this scenario, this becomes a false. Then you can enter into critical section. While leaving, you set your flag of 0 is equal to false. That's it. P0 one round completed. Can he enter into second time? Let us go one more time. Again P0 got chance. He set flag of 0 is equal to true. While flag of 1 is equal to true, already flag of 1 is equal to false. It is not changed, not yet changed. Then this condition becomes false. He can enter into critical section. So a process can get n number of times to enter into critical section as long as it is freely available. Right now, as flag of 1 is false indicates that P1 is not interested to access the critical section. So P0 is interested to enter into critical section. So no issues. Then how about bounded waiting? When you say that bounded wait, whenever a process to access a critical section, if somebody is already there, then your waiting time is supposed to be finite or bounded. You see, flag of 1 is equal to false initially. Let. So P0 obviously get chance because this flag becomes false. P0 is initiated. He is saying flag of 0 is equal to true, and I'm checking a while condition. While I'm checking for other process status. Flag of 1 is equal to true. According to this, this becomes false. Then he can enter into critical section. In the meanwhile, this guy, in the meanwhile, this guy, P1 preempt, P1 preempt P0. Then P1 got a chance. He's trying its side. Flag of 1 is equal to true. He is setting himself flag of 1 is equal to true. Now is cross verifying while flag of 0 is equal to true or not. According to this scenario, already you made flag of 0 is equal to true, which indicates that P naught is inside the critical section. Therefore, when this condition becomes true, he will be under where? Waiting. How long he will wait? How long he will wait? This is the timing. This is the time scenario. How long he will wait? As soon as this guy made flag of 0 is equal to false, then automatically the guy who is under waiting will get an alert that your condition becomes what? Flag of 0 is equal to false. Then this condition becomes false. So waiting is removed. When this condition becomes false, waiting is removed, then P1 can enter into critical section. So what is the bounded time? Only one process. Before you, there is a one process ahead. That is not nothing but P naught. The bounded waiting is also satisfied. But what is the major problem? I said deadlock. How deadlock comes? We already seen this. Let me show you clearly. Imagine let flag of 1 is equal to false. You may use 0 also. If flag of 0 is false, you need to check with P1. If flag of 1 is false, you need to give access to P naught. Opposite you need to give. Now I am writing first P naught initiated, line number 1, flag of 0 is equal to true. Exactly here, soon after first line completed, P1 preempted P naught, because in parallel execution, anywhere you can give preemption. Then who got the chance? Who got the chance? This guy got the chance. He is entering line number 1 at P1 side. What is that? Flag of 1 is equal to true. Right. Then he is executing line number 2. What is that? While flag of 0 is equal to true or false. Already you made flag of 0 is equal to true earlier, still it is inactive. Therefore, this condition becomes true and the semicolon indicates that do skip. You can't enter into the next line. Then you are under waiting. Who will get the chance? Opposite process. What is the opposite process? This guy. This guy executes line number 2 because he suspended at line number 1. So line number 2 is checking while flag of 1 is equal to true. And this is also true. Surprisingly, because already you made flag of 1 is equal to true, then as you got the chance, after that guy is under waiting, then this indicates that you're also going to be under waiting, which indicates that P1 is waiting for P naught and P naught is waiting for P1, and indefinitely it leads to a concept of deadlock. That's why you can't give the preemption just after flag 0 or between. You can't give any preemption here and here. If you give a preemption between this and this, then it surely fall into deadlock. If any process give the preemption before 1 or after 2, no issue. Before 1 or after 2, like previous. Before 1, after 2. Here, the preemption is given after second line. Therefore, already the while condition is satisfied. As you are entering into critical section, here you are making you to wait. But in this case, it's not like that. The preemption came either in the P0 process or P1 process. The preemption came in between 1 and 2. That's why it leads to a concept of deadlock. So this problem is eliminated in Peterson solution. This is a very, very important and real-time implemented in two-process solution concept. What is a Peterson solution? It uses the concept of turn variable, and it also uses the concept of flag array. It uses both solution, Dekker solution 1 and enabling and disabling flag solution, and flag of 1, maybe 0 or maybe 1. maybe 0 or maybe 1. So the Peterson uses both the shared variables. One is a turn variable, the other one flag array. Let us see the solution. Flag is shared and global Boolean array. Turn or wanted is a Boolean variable. Flag of 0 or flag of 1 can be true or false according to the previous solution. Initial values of turn can be 0 or 1 according to Dekker's algorithm. And as usually rules, in order to access a critical section, a process must acquire the lock. Once critical section is completed, process must release the locks. That is the concept. Otherwise, other processes are getting to be under waiting. Advantages, all three. There is no issue at all, no deadlock, no starvation, whatever it may be. It's all satisfying mutual exclusion, progress, and bounded waiting. What is the algorithm? Let us look into it. So turn may be 0 or 1, flag of 0 may be true or false, flag of 1 may be true or false. And what is the story here? This is line number 1, flag of 0 is equal to 2, line number 2, turn is equal to 1, line number 3, while condition, and line number 4, critical section, line number 5, exit section. Here also, line number 1, line number 2, line number 3, line number 4, line number 5. Each process undergo 5 steps. But preemptions are allowed anywhere to anywhere. He may give the preemption between 1 and 2. He may give the preemption above the 1, or he may give the preemption after the while. Anywhere, a process can disturb others at anywhere. Let us see that what will happen by taking all the case studies. I'm checking first of all mutual exclusion property. Mutual exclusion indicates that only one process is allowed to access critical section at an instance of time, which indicates that no two processes can access critical section at the same instance of time. The mutual exclusion I am satisfying first of all P0 side and P1 side. So P0 is initiated, turn can be anything, flag can be anything. That is the algorithm beauty. It need not be initial value false or true, 0 or 1. It can be anything. And that too, they are global variables. They can have access to turn. They can also have access to flag. That is the power of this. What the algorithm step number 1? Flag of 0 is equal to true. Flag of 0 is equal to true. See this? P0 is initiated. You may initiate P1 also, never mind. Then turn is equal to 1. Turn is equal to 1. Then while condition, while we are checking for other process, while turn is equal to 1, and then flag of 1 is equal to true. Okay, let us see the condition. I am setting the flag. I am setting a turn value. Now I am setting while turn is equal to 1. Yes, it is true. While turn is equal to 1. Yes, it is true. And flag of 1 is equal to true or false. If it is true, you will be under waiting. So now I am giving here an analogy. Let flag of 1 is equal to false. Then what happened? This condition is broken. Though it is a true, this becomes a false. Therefore, you enter into critical section. While leaving, you supposed to set your flag to false. And I am leaving, I say that flag of 0, that is a process not equal to false. Okay, then in this case, he is also doing the same story. P0 is executing secondly. He is saying flag of 1 is equal to false, and he is cross-checking. Turn is equal to 0. We are checking for P0 condition while turn is equal to 0, and then flag of 0 is equal to true. Let us see this condition true or false. If this is true, you will be under waiting. If this is false, you will be entered into critical section. Turn is equal to 0, it is true. But flag of 0 is equal to true? No, because flag of 0 is equal to what? False. Then this condition is broken. Then you can enter into critical section. Then while leaving, you set flag of 1 is equal to false. That's it. It is satisfying ME. But here I have not used any concept of preemption. Now I will give preemption anywhere to anywhere. You can give preemption here or here or here or here, anywhere. So I'm checking mutual exclusion property with the preemptions. So even under preemption, no issues. It's wonderfully working. P0 and P1. So I'm writing with the P0 and I say that flag of 1 is equal to false. What will happen? Line number 1 is setting flag. Flag of 0 is equal to true. Okay, that's it. Give the preemption here. P1 preempt P0. Then immediately P1 got the chance. P1 is executing line number 1, that is flag of 1 is equal to true, and he is continuing second line, turn is equal to 0, and he is continuing third line while turn is equal to true, and then flag of 0 is equal to true. So flag of 0 is equal to true. Am I right? Because just latest P0 did this. So turn is equal to true. This is true and this is true. Simply you will be sending where? Waiting state. Then who got the chance? P0. Now in this case, P0 got chance back. P0 got chance. Then let us go there. P0 is executing. P0 is executing. It's line number 2. So P0 is executing line number 2. What's line number 2? Turn is equal to 1. Line number 3. While turn is equal to 1, and then flag of 1 is equal to true. So turn is equal to 1. Yes, it is a true. And then flag of 1 is equal to true. So flag of 1 is equal to what? True. Then therefore, this guy got what? Condition becomes true and you will be under waiting. Clear? Now who got the chance? This guy is under waiting, this guy is under waiting. Now who got the chance? P1 got chance. Please observe carefully. P1 got chance. Now P1 again checking while condition. Again checking while condition. While turn, please observe carefully. While turn is equal to 0. No, because you made turn is equal to what? 1. So this condition becomes false. When this condition becomes false, you can enter into critical section. Right now, who is in critical section? P1 is in critical section. Then after P1 in critical section, you will say that flag of 1 is equal to false. Then who got the chance? P0 got the chance. And here flag of 1 is equal to true. It is not true because he made false. Then P0 can enter into critical section. See the beauty. You can test on your own anywhere. You can give the preemption at line number 1 or before line number 2, before line number 3, whatnot. But mutual exclusion property is completely satisfied. Let us see progress. The progress indicates that when no other process is interested to access critical section, then if anybody is requesting to access critical section, you can get it. I say let a flag of 1 is equal to false initially. You can also do with the flag of 0, I don't mind. So I am setting flag of 0 is equal to true, and I am saying turn is equal to 1 while condition turn is equal to 1, and then flag of 1 is equal to false, sorry, is equal to true according to algorithm is equal to true. True or false? If this is true, it will be kept under waiting. If this is false, it will be kept under critical section. So flag of 1 is equal to false. Therefore, this entire condition becomes false. Then you are entering into critical section. While leaving, you set your flag is equal to false. That's it. One round completed. And next time, if P naught again would like to access critical section, is it possible? Let us go back. Line number 1, flag of 0 is equal to 2. Line number 2, turn is equal to 1. Line number 3, turn is equal to 1. Yes, it is true. And then flag of 1 is equal to true. No, it is a false. This is a false. Then condition is false. You can enter into critical section. While leaving, you set flag of 0 is equal to false. So here it satisfied what? Progress also. And third property, bounded waiting. What is the bounded waiting? When one process is in critical section, if any preemption came from other process, then that process kept into waiting. How long? Soon after completion of other process, you will be getting a chance.